spectrograph, then this photoplate, undeveloped, would be loaded through this vacuum lock and positioned right along this focal plane in the instrument. And then you would run the experiment, but the point that we want to make here is this makes the instrument a mass spectrograph.
Yeah.
When this spectrum is recorded, all of these ions are impinging upon the plate over the whole mass range at the same time. And that's why we have what they call the integrating beam monitor. What one would do would measure the integrated current, and when it got up to a certain level, you would know then that you had exposed the photoplate well enough, and you would want to move it, essentially move it to the next location so you could record a different spectrum. And so you could record spectra from different compounds on the same photoplate.
Right.
You could record a mass calibration compound on the photoplate. You can record up to, as you indicated, close to 30 different individual spectra on the photoplate. But basically what we have is this is the photoplate that came out of the instrument after spectra were recorded on it. And it was developed just like you would develop a film. And right now that plate, we have a similar type plate, is mounted in the device for reading the data. And what you can see then is, if you can look up here, you see that the lines on the photoplate are shown. So the idea is that what happens is there's a photomultiplier tube back here, and as this plate is scanned across,
Yeah, all the scanning is automatic. He's doing it by hand right
I'm
now.
manually scanning it now.
Yeah.
But
Scans across each one of those peaks, and it reads off the darkness of the peak, which is really the optical density, and that is proportional to the intensity of the ions.
so what you would end up getting then is a mass spectrum that looks kind of like the one that you would record from the
Yeah, you
photographic
would.
recorder.
Yeah.
And the thing that's really interesting here is how close together two lines can be but still be resolved. And we might have to get up real close then to show that, because
We should be able to find some doublets. I can see some doublets right in here,
okay.
and you probably will see even triplets in some places. This looks like the low mass end of the spectrum.
You want to go up to the high mass end? Well, we're about the middle here.
Maybe it is. This is really a pretty heavily exposed spectrum there. These lines down here are a lot sharper.
Yeah, I think this might be a mass calibration standard, you think?
It
maybe?
might be, yeah.
The top one. So I think this instrument had around 30,000 resolving.
Yeah, it's little. The original specs were quoted about 31,800. Really, with the photoplate, you can do better resolving power than with a slit. And I might point out also, with a photoplate, you're not using the slit down here. I mean, this is the beam focus on the photoplate.
You're just seeing the image slit.
So you can really get better resolution on a photoplate than you can by using
the point detector.
The electron multiplier, and the slit goes before it. One of the reasons being you can expose the plate for 10 to 15 minutes, and you may just have a few ions coming in there, but you can get enough to make a peak.
So then, originally, this data was essentially translated into a recorder where you would have peaks as a function of time as an analog recording, but then the data was fed directly into a computer and digitized, and then from there it's processed. So this technology, I'm not sure many people use this anymore, but it is exemplary of what was done. And I believe, I know for a fact that Klaus Biemann used this technology in his research at MIT when he was doing his
and they used it
early
at Baylor
peptide.
College of Medicine. Jim McCloskey and Dominic Desdario, they were using it there. The other thing I guess we can say here is all this is done automatically. You set the thing up and it was scanned across the photoplate like this. It takes about 30 minutes to scan across it, and then when it comes to the end down here, it shifts the photoplate up to the next spectrum. See, these are two separate spectra in here. So it's shifted up and then it would scan back. And keep on doing this for 30 spectra if you have as many as 30 spectra on the plate. And all the time it's being recorded with this giant piece of equipment over here, which is really a forerunner of a mini computer. recorded on magnetic tape. And from there you take the magnetic tape to the central computer, which is probably an IBM 370 or something like that,
Yeah,
huge
back then.
computer, and let them take the data off the tape and then send the data back to you depending on whatever programs you're using.